In this video, I'm going to describe how to take 5 volts from the USB cable and turn it into 3.3 volts, which will power our microcontroller and all of our other chips. We're going to use the L493 L4931. It's called an LDO, linear, or it's low dropout operating voltage regulator. So this is a voltage regulator that needs a little bit more than the voltage that it's making to be able to make that voltage. So we will have 5 volts from the USB cable go into our voltage regulator. This is the L4931. It has a ground connection and it has an output of 3.3 volts. So that chip, it looks like it's a TO90 package. It looks a lot like a 3-pin transistor, very standard package. And in the datasheet for this chip, it has kind of a weird drawing. So they draw a bottom view. So this is the bottom. And there are 3 pins. And it's out, ground, and in, which is kind of weird to kind of draw that bottom view. So I'm going to draw a more traditional like 3D view. So here's the front flat face, the round part is behind. We've got 3 pins, and that means that this is in. No. The middle is ground. And this is where we could easily mess it up. So if you put it in backwards, it's probably not going to work, and it's going to get hot. So what we're going to do is we're going to build it. We're going to check it with the multimeter to make sure that we're getting 3.3 volts out, make sure that it doesn't get hot. Once we have that, then we can apply that 3.3 volts to the chips that we're going to be powering. So we don't want to build all of our circuit and then turn it on and find out the regulator was wrong. We're going to build the regulator first, then we'll go and we'll build the PIC circuit. So let's try again. From the bottom view, facing the front, the leftmost pin, and I built this, so that's why I'm hesitating, because I'm pretty sure the leftmost pin is the out pin, and then the middle is ground, and then the out is in. Sorry, the rightmost pin is in. So I'm going to plug that into my breadboard, and we're going to look at a few things on this board. We've got a breakout from Pololu that takes a micro USB and gives us the 4 wires that are in that cable. So I'm going to make a ground connection to my breadboard from the ground pin, and I'm going to take V-bus, which is the 5 volt, and apply it to what I think is the V-in pin to this voltage regulator. And then I can have a ground wire from the voltage regulator go to the ground rail. And so I've got ground on this rail, and I've got ground on this rail, and at the very bottom of my board, I'm going to connect my ground to my ground. I'm going to connect my power rail to my power rail. So when I'm done, I've got power and ground, power being 3.3 volts in ground, and another 3.3 volts in ground on both sides of my board. 5 volts will only exist in this row up here for V-bus. Okay, so back to the regulator. I've got 5 volts coming in, ground, and now I've got my output pin. I'm going to take that output voltage, and I'm going to swing it around to this side of the board. It doesn't really matter. So now if I power up this regulator, I should see a nice clean 5 volts, and I should see a nice clean 3.3 volts. So I'm going to take the power from my end scope temporarily, use that to power my regulator. And so one thing I might notice is that my computer might complain. If there's a short in this USB cable, my computer would try to turn off that USB cable. It did make a little noise, so I don't think that's happening. I prepared 2 of the wires here, so I'm going to have a ground wire and a sense wire. So first I'm going to read 5 volts on my multimeter. Wires, so I've got ground and ground, and this should be 5. So apparently my computer outputs a little bit more than 5 on the USB cable. And then I'll switch this over. And there's my 3.3 from the regulator. Now, most regulators actually don't work very well without what they call bypass capacitors, a stabilizing capacitor on the output. So this particular regulator asks for a 1 microfarad or a 0.1 microfarad on the input, so on the 5-volt side. So I've got a 104 capacitor here, so that's a 0.1. So I'm going to put that from 5 volts to ground, maybe here. Get that in. And it also asks for a kind of like a larger capacitor. It asks for a 2.2 microfarad. I'm going to add a 10 microfarad, and this is a tantalum polarized capacitor, so carefully look at the plus sign on one of the legs, so you don't plug it in backwards. So over here I've got my 3 in ground. So I'm going to have my 3 to ground, the 10 microfarad, and I'm going to throw in a 1 microfarad to boot. So the reason for the kind of big capacitor and a small capacitor, the big one provides like large amounts of current to say, let's say something suddenly turns on and draws a lot of current. This bulk capacitor, the big one, will provide that current for the short period of time. And then high frequency noise will get suppressed by a lower value capacitor. So now I've got 0.1 micro on the input, and I've got 1 micro and 10 micro on the output. And I should be able to go back and just verify that I still have my voltages. So I still have a 3. I still have my 5. Now, as we're building, for instance, if we're powering everything with the N-scope detects a short circuit and will turn itself off if we do something wrong. Now that we're powering just directly from our USB cable into a voltage regulator, we have no indication if, as we build future items, we have a short. So the way we'll detect that short is we're going to have a power LED, an indicating LED here from 3.3 volts, that will always be on. And if, as we're building, that LED is not on, we know there must be a short. So I'm taking 330 ohm resistor, and I made the mistake of cutting this LED's legs to be equal length, so I forget which side is positive. So I'm going to try plugging in both ways. That must be backwards. Okay, so now I have a lit red LED because the 3.3 volts is available. If I unplug it from my computer, the light goes off. So I have no on-off switch other than just plugging the power in and out. So let me add these things to my circuit diagram now. I've added a 0.1 microfarad on the input and both a 1 microfarad and a 10 microfarad. This one has a positive lead because it's a special kind of capacitor. And I took that 3.3 volts and I went to red LED with a 330 ohm resistor in series to limit the current. So now I have a nice clean 3.3 volt power supply. If I wanted to see maybe there's some ripple or something, I could check that with my N-scope. But now I should be ready to build a more complicated circuit and power it with the regulator.